All right. So what does a reciprocal, like in just mathematics, look like? And then what's its graph look like? So to do a reciprocal, we took, in this case, 4.5. We converted it into an improper fraction, 4 times 2 plus 1, 9/2. And then you switch the numerator and the denominator, and that's your reciprocal. Okay, so if we go to these examples right here, we're just going to take reciprocals of different expressions. Okay, so we're going to kind of skip around in here. You gotta look at the screen. Okay. Yeah. What? Put away. So if we were writing the reciprocal of 3, 1/3, right? When you're writing a reciprocal of a negative, it's still negative. So the reciprocal of -2 is still -1/2. The sign, it doesn't affect the sign. So the reciprocal of 2 3/4, well, I turn that into an improper fraction, and then I swap the numerator and denominator. All right, now, if it's an expression, so in mathematics, guys, when you see the word expression, that just means it's got variables and numbers in it. Okay, so if I said, what's the reciprocal of 1.5? Well, you typically don't write decimals in numerators and denominators. Okay, so what we're going to do is, for A, is convert that into a fraction. So 1 5/10, because that's what that decimal is. Now turn that into an improper fraction. Okay, so that's 10 plus 5, 15/10. And now swap the numerator and denominator and reduce it to lowest terms. So 2/3. All right, if I wanted the reciprocal of x, 1/x. I want the reciprocal of 2x, 1/2x. Okay. The reciprocal of 3/4d, 4d/3. Okay, the reciprocal of h. So you're not doing anything different. It's still, you're just swapping the numerator and the denominator. That's just basically reciprocals. Okay, now when you take a number and you multiply it by its reciprocal, what happens? Yeah, if I did 4 times its reciprocal, I get 4/4, which is 1. So 7/11 times its reciprocal, 77/77, 1. 2/x times its reciprocal, 2x/2x, 1. So a value times its reciprocal, an expression times its reciprocal is going to equal 1. Okay. All right, so what we're going to do is graph a reciprocal function and see what it looks like. All right. Probably because of the big mullet, that giant mullet that he's got there. Okay. And his head is rather large. You should see the size of his football helmet. You could take a bath in it. It's a swimming pool. Okay. All right. Now, reciprocal function. So you're gonna what we're gonna do on Desmos now is we're gonna take a linear function that looks like this. If I did y equals 1/12 x, okay, you don't need to draw this, just look up here. Okay, if you were to graph this, this is a line. It's going to be a diagonal line of some kind. It's going to look something like this. It's going to go right through the origin, and its slope is 1 up, 12 right. 1 up, 12 right. And there would be our next dot. And that's what it would look like. There'd be a line that goes through those two dots. Okay? So that's the equation y equals x over 12. 1/12 x is the same as x over 12. Do you see why? No? You're just doing this. X over 12. It's the same thing. Okay, now, what's the reciprocal of this function? 12 over x. And what's it going to look like? Okay, here's the weird part. When you do the reciprocal of a line, it is going to be a hyperbola. It should be a straight line. It's not. Yeah, it's not. Here, the really freaky thing is if you do the reciprocal of a parabola, like we got done doing these kind of graphs. If you did the reciprocal of that, it would end up looking like this. Those are going to be reciprocals. Okay, but right now we're just going to start with linears. Okay, so now what I'm going to do is I'm going to show you why this is. How does a line turn into a hyperbola? Okay, all right. So if you looked at this equation right here, all right, or you look at this equation, let's look at this one. If I multiply both sides by x, this is the same as x times y equals 12. That and this are the same thing. Same thing. All right, so if you open up the Desmos graph now, you guys still here in studio? Yep. Okay, so now I'm gonna choose the one that says investigate. A dateline investigation. Okay, so go ahead and sign in. Okay, I'm gonna sign into mine. Sure. Now there are some slides in here that you'll be answering, so you want to be sure that you fill in each one. It's going to flip over the x, Okay, so let's see. Well, if it flips over the X or flips over the Y, the result looks the same. Because, and the reason is, this is an odd function. If you took this and you turned it upside down, it's going to look the same. So if I flip this over the X and flip it over, or flip it over the Y, I get the same result. All right, so let's see on here. So now we're just gonna make these negative 12. So one of them's positive, now make the other one negative. So go ahead and type those in, and then make an equation to fit it. Yep, you can see the 1/2 right over here. So it's switching to the other two quadrants. So you guys were right. And then there's my model. And if you look, it made the K value negative 12. And if I just click on it, there is my function. That's the hyperbola that I get. And this one, it's linear equation that belongs with it would be y equals x divided by negative 12. Whoops. And there it is. So if you took that line and did its reciprocal, you get the hyperbola. And now, guys, here's an important thing about a hyperbola. Look at any point on the hyperbola. Even if it's a fraction, if you multiply those two fractions right there, you're going to get 12. You're going to get 12. So what that does is that gives you a really easy way to graph these things. Okay, so for example, if you go back to your packet here and go to, oh, that one's 12. Let's go to, which one's this? X. Right here, go to 4B. I'm going to show you how easy these are to graph. Okay, if I said, sketch the graph 8 over x. You guys find it okay? 191. Okay, so if we draw ourselves an axis, so just sketch an axis. Okay, now we know when we do this, it's going to look something like this. It's going to have one curve, and then it's going to have an opposite curve. Well, how do you know where to draw those curves? Okay, now, what do you know about every coordinate that's on here? They're going to be factors of 8. So if I was just eyeballing this, I know that 1/8 would have to be on the graph. I know that 2/4 would have to be on the graph. I know that 4/2 has to be on the graph. And I know that 8/1 has to be on the graph. 1, 2, 3, 4, 5. 2, 3, -1/8. So these are the points. This is the point 4, 2. This is the point 2, 4. This is the point 1, 8. And that's the point 8, 1. So it makes graphing these really simple. And if I know the other branch is going to be over here. 5, 6, 7, 8. Okay, so now these are both negative. So -1, -8. This one here is going to be -8, -1. Okay, and then these two guys in the middle, -2, -4. See how easy it is? If there's a numerator in what? Okay, now you said x over 12?
Yeah.
This is a line. If it was 12 over x, now it's a hyperbola. Yeah. That's the reciprocal function. So if I was doing C, if you solve that for y, you get y over 16x. So now your numbers on here are all going to multiply together to be 16. So when you're graphing these, that's all you're having to think about. So it's pretty easy. So they're all going to look similar. It's just how steep the curves are. Now, if we put a negative on it, like 3a, all right, well, we know now that that's just going to flip here, and now the one down in the third quadrant is going to go there. Now, when you're graphing these, you know how I make a big stink over, you got to label stuff? Okay, so just label a few points on here. That's all you got to do. So if I was actually graphing this, if I was doing my homework right now, and I wanted the person looking at my homework, which is me, to understand what I did, I would just put like 1 point on here. And I'd say, okay, this is 4, -2. And then that tells the person, okay, this one would be -2, +4. So graphing reciprocal functions is pretty straightforward. Okay. Now, what we're going to look at next is like some domain and range stuff. When did we bell ring here? 5? Okay, let's stop here for now, and pick this up tomorrow. But today you learned that a line reciprocated turns into a hyperbola.